Hi students, in this class we derive the equation for a general solution of wave equation. Right, so already we derived a wave equation. So if you have any doubt, please refer my video on wave equation. That states del squared E is equal to mu epsilon dou squared E by dou t square. Similarly, del squared H is equal to mu epsilon dou squared H by dou t square, right? So let us assume this is equation number 1, equation number 2, right? So I can write del squared E as, where del squared E is equal to dou squared E by dou x square plus dou squared E by dou y square plus dou squared E by dou z square. Like that we can write del squared H also, fine. So you see this equation is a vector equation, right? And we can convert into scalar equation, right? Vector equation is very difficult to deal. Let us see that, right? So let us assume that our wave is propagating in x direction. So wave propagation in x direction, right? And E and H are perpendicular, right? So that is E in y direction and H in z direction. This is the way we assume, right? So wave propagates in x direction. So what happens? Dou by dou y is equal to dou by z, dou z is equal to 0, because the wave is propagating only in x direction. So the variation along y component, y direction is 0. Similarly, the variation along z direction is 0. So what happens? The equation 1 is reduced to only dou squared E by dou x square. Remaining thing will be cancelled. So 1 implies dou squared E by dou x squared is equal to right hand side mu square mu epsilon dou squared E by dou t square. Fine. So this is what the equation turns, right? So it is E. Okay. So let us assume that E is a vector, and we know that E is a vector that can be written as Ex I vector, that is a component of the vector along I direction, component of vector along j direction plus component of vector along k direction, right? So here you see here we have three scalars Ex, Ey and Ez, fine. So here you see this equation is equivalent to three scalar equations, right? One vector is equation is equal to three scalar Ex, Ey and Ez, right? So what is the thing? We do that, we do some manipulation here, right? So we assume that the wave propagates only, or wave has only Ey component, because E is in y direction, right? Wave is propagating in x direction, so electric field has a y component and magnetic field has only z component, and wave propagates in x direction, that we know, wave propagation, right? So E has Ey and Ez component, right? So let us see that how can we represent this. This can be represented as, okay, let me draw properly. So it is like this, fine. So perpendicular, so it appears, oh, it's not appearing properly, fine. So what happens here? E has y component, okay, it's like this, right? This is x, this is y, this is z direction. So electric field is in y direction and magnetic field in z direction, Ez. So when wave propagates in this direction, it appears that this plane is moving, right? This is what we know uniform plane wave, right? So we take only that one. So what we are going to do is, instead of this three component, we take only one component, that is EY only present, right? So EY only present, others are absent, means this equation becomes dou square EY divided by dou x squared is equal to mu epsilon dou squared EY by dou t square, right? So this is what right, we made it is a scalar equation, right? Earlier we had a vector equation. This is a scalar equation. It is a second order differential equation. Okay, so this equation has the solution of the form. What's the form? This equation has E, right? That is have a y component only. So E x of t is equal to f1 x minus v naught t plus f2 x plus v naught t. This is the solution of this equation, right? Why? See, we take only electric field as y component and it is a function of x and it is a function of t. So E x of t, Ey x of t. Okay. So that f1, f2 may be any sin theta, cos theta or anything, right? Depending on the application. So what will happen here? You see fx1 of x of v x minus v naught is indicating wave propagating away from source, right? This implies a wave reflected back to the source, minus. The plus indicates wave reflected back to the source. That is a very, very important point to be noted, right? So, but in free space, we don't have any obstacle to reflect the wave back to the source, right? In free space, no obstacle to reflect the wave. Yes or no? It's a free space, right? So we don't have any obstacle. So this part will be 0 because it is a reflected wave. There is no reflection. So what will happen in free space? The solution is Exy of t is equal to f1 x minus v naught t. This is for solution in free space. Okay. So these things we must know very clearly, right? And moreover, you see how V naught has come. You know that this is the equation. Here, what do you call? V naught is given as 1 by root of mu epsilon, right? Or mu naught epsilon naught in free space. Fine. So that thing we have to know. So this is the equation. We will derive this in detail in the coming videos. Okay, so how can we draw this diagram? How the wave will appear? The wave will appear like this. Here you see, let me draw. It is okay. This is x-axis. This is f of x, right? So we can draw like this. This equation diagram will be. You see, the equation is Ey f x of t is equal to f of x minus v naught, f of x plus v naught, f1, f2. Okay, so let us see here when t is equal to, it is like this. It is like this. What is that? Here when t is equal to t1, we will have a wave like this. When t is equal to t2, the waveform will be like this, right? So when t is equal to 3, the another wave will be appearing, right? So this is what a general solution of uniform plane wave, right? So I hope you understand everything clearly. So any wave is it's a combination of wave propagating away from the source plus wave reflected back to the source. That's what we concluded, and vector equation becomes scalar equation. Why? Because we cannot deal with vector easily, so scalar is easy to work. That's what we convert into this type. Fine. So with these assumptions, wave has only EY component and propagating in X direction, right? So I hope you understand everything clearly. If you have any doubt, please ask me in comment section. Thank you.